morning, everyone. I'm Laura Pellegrini, and I'm a PhD candidate at Politecnico di Milano. And I'm here today to present the article Decision Support System for Occupancy-Oriented Facility Management, Methodology and First Results, which was defined and realized with Dr. Seghezzi, Professors Tagliabue and Giuda, and engineers Schievano and Alessandro Tucci. So the context of this research, which is my PhD research project, is the facility management of workplaces. And so I should introduce the context of this research, which is the evolution of workplaces from traditional workplaces to other work practices like work from home and work from anywhere. Basically because there is a large variability of work activities, and the workers are trying to reach a higher work-life balance. And so it causes a variable occupancy in workplaces, which is not anymore fixed and constant. And so about the diffusion and introduction, growing introduction of remote working practices in the Italian context, the remote working practices are defined in the Italian laws by Law 81 of 2017. And the focus is on the flexible articulation of time and place and the work-life balance, and the focus on the worker. And an important part is the individual type agreement of the remote working practice, and also the organization by phases, cycles, and objectives, which defines a real flexibility of work time and places. And also the law defines the right to disconnect and equal pay and treatment. These are the most the main benefits and limitations of remote working practices. So an improved work-life balance, growth in employee motivation and involvement, and higher satisfaction with respect to the job and to the relationships with the colleagues. Also, reduced mobility for the worker, but there are also some limitations, which are the use of technologies, the planning and managing, and the perception of isolation and difficulty of organization. Which is important of remote working practices is the real paradigm shift. So we pass from a command and control system with the control as a tool of management to the learning organizations. So organization in which there is a creation of shared value between the workers and also the manager. There is a relationship of trust and a focus on the team psychological safety, and also on the responsibility of the individual. And so we pass from a static system and space with the single works and private workstations to a dynamic system and space. So avoiding or reducing the presence of private workstation workspaces for activity-based workplaces, which are places that are planned for specific activities and that are usually more suitable for for those activities. Causing a decreased fixed costs of real estate for the organizations. And so this is an important benefit also for organizations for the introduction of remote working practices. And what happened during and what will probably happen after the actual pandemic situation, that before the pandemic in the Italian context, there was a little application of remote working practices, while after this period is expected that higher levels of remote working practices will be maintained by private as well as public organizations. And so all these aspects related to the remote working practices are increasing even more the high variability of occupancy in buildings during the operation and maintenance phase. And also, this variability is not considered in the definition of facility management strategies. On the contrary, during the design phase, spaces are designed according to fixed and standardized use-based occupancy values. And the user actual needs and feedback from previous experiences are not considered in the design phase. So all these aspects lead to the existing buildings' actual spaces that are inadequate, typically inadequate for the actual uses. And also there are large parts of unutilized spaces for most of the time, and poor values of space use and cleanness that lead to a decreasing well-being, user well-being and satisfaction, and consequently a decreasing productivity. And so to overcome these issues, this research project presents the definition of a decision support system based on occupancy data and space uses to support the optimization of space organization and facility management services planning, with the objective of supporting the decision-making processes of facility manager, to suggest optimization for facility management services and space organization, and also, most importantly, to move from a static occupancy schedules to more flexible use and management of spaces, making owners, facility managers, and also users aware of the improvement and possible advantages deriving from, resulting from monitoring and better management of spaces. So these are briefly the steps of the research methodology: building preliminary analysis, the definition and installing of the IoT sensor network, the actual definition of the decision support system, which is defined as a dashboard, and the analysis of the scenarios through key performance indicators. So these are the preliminary analyses that were performed on the building selected for the case study, which is the department of the building was in the Department of Architecture, Built Environment and Construction Engineering of Politecnico di Milano. Post-occupancy evaluations were used to define the analysis, to define the functions and services of the building, and to analyze functions and services in relation to occupancy, all to define the critical areas to be monitored of the building through the system, and also to plan and install properly the sensor network. An important part of this planning was the definition and overcoming of the privacy issues, and to ensure that the user data protection. And so it was decided that only corridors and common areas will be monitored. Also, there would be an anonymous monitoring of users. Users are recognized as humans by the embedded deep learning algorithm, which is actually embedded in the cameras that were the sensors selected for the application. And the agent recognized by the algorithm is translated into an anonymous agent that cannot be linked to a specific user identity. In addition, users have been fully informed before the installation of the system, and information science and detailed report were defined to inform the users about the system. So the decision support system has the objective to support the facility manager's decision about the planning of facility management services over time, organizing and redistributing spaces over time, and assigning functions and number or type of users to the spaces. Also, at the same time, to define the decision support system, an analysis of cleaning plans and contracts was performed because the specific application was focused on cleaning services. And so the frequency of activities, the parameters for planning and planning period were analyzed. And so the main objective of the decision support system is to give insights on current occupancy patterns and space uses and compare occupancy scenarios and current conditions to support the definition of optimization strategies. And this decision support system was defined as a dashboard with two modules: a data analytics module to analyze the current conditions of the building in relation to the occupancy, and some scenarios to be compared in the scenarios comparison module. This is the main data flow and outputs of the dashboard. So as I said, the user movement are anonymously monitored, then are sent to a database, which sends then the data to the data analytics module and the scenarios comparison module. And there is also a web-based platform to monitor the system functioning. The outputs of the dashboard are graphs and charts in the data analytics part. New knowledge analyzing these graphs and charts about space users percentage, vacancies percentage, occupancy patterns, and also a list of prioritized cleaning activities. And then obviously from the scenarios of comparison module, the occupancy scenarios which are compared with the current conditions to define strategies for optimizing space organization. This is an example of the pages of the data analytics module. So there are both the blueprints of the various floors of the building, but also graphs with the time of use of the spaces, so the use of spaces over time, but also the average values of use of spaces, but grouped for the space type, and also the percentage of used and not used space over time. And so all these graphs and charts and web pages of the report, which was defined with data sheets and then analyzed with Power BI, defining the web pages of the report. These pages allow to analyze the current condition of the occupancy of the building. While the scenarios comparison module allows to hypothesize new occupancy values through datasheets, considering space types and specific time frames. And so through the new occupancy values, which are defined by from the analysis of the current conditions, so if there are spaces that are not used and at the percentage of 100%, these spaces could hypothetically defined as used at 100% by introducing new functions, for example, or introducing new users in these spaces. And then these occupancy scenarios are compared with the current occupancy patterns, highlighting the differences and highlighting the increase and decrease of facility management activities, because an increase in the use would cause also an increase in the, for example, cleaning services. And then the result of the KPI application. The three KPI defined to evaluate the scenarios are the percentage of use, the percentage of users occupying the building, and the evaluation of the economic aspects. So these are finally the expected impacts and further developments of the research. The research is expected to support data-driven decision-making processes, to support the increase of building adaptability to changing conditions and needs, to support an efficient transition towards more flexible post-pandemic workplaces, and to optimize facility management activities. In particular, cleaning activities were analyzed in the specific application. And the possible further development are automating the phases of data cleaning and classification, which were in this case manually performed, and to introduce controls and other tools to act on the physical building, defined an actual digital twin for facility management. For example, it could be defined an application to select the spaces to be occupied for a specific period of time, and consequently the analysis of the occupancy will be defined also by this application that will help to act directly on the building, on the free spaces, for example. And finally, some criteria and guidelines for occupancy monitoring and simulation and for future design processes. And thank you for your attention.